one of the questions I would like to address with you is, and it's a question I've always asked myself actually, because it's a question that is, between mathematics and physics. Because as you know, when we talk about infinity, it's more related to mathematics, at first sight at least. Well, since Cantor, at least. But when we are talking about indeterminacy, right away we are thinking about quantum physics, we are thinking about Niels Bohr, the Copenhagen School, and all those people, even Heisenberg, of course Heisenberg,
right,
with the uncertainty principle. That is not maybe exactly the same thing, but we will come back to that. And so at first I will say, do you think there is some kind of a relation between, do you see some kind of relation between infinity and indeterminacy, like infinity in mathematics and indeterminacy in physics, at least in quantum physics, maybe in astrophysics too? I don't know.
You know, that's a very good question, and people have come up to me and asked many times over the years.
Shit, so I'm not original. I'm not that original. That feels bad.
No, you're very original, Raphael. I would say I don't see, absolutely direct connection. Because mathematics is one field and physics is another. However, at the conceptual metaphorical level, yes, there is a deep connection, I think. Because in my work and in algorithmic information theory, the notion of randomness is absolutely fundamental. And that's a kind of mathematical indeterminacy. And then in quantum mechanics, the notion of randomness is also extremely fundamental. It's not a lack of knowledge, it is intrinsic randomness. The world, according to quantum mechanics, is in principle non-deterministic. Nature, as Einstein protested, God doesn't play dice, but it looks like...
Famous sentence.
Yes, but it looks like God does play dice, a lot, all the time. And...
Please, God, can you stop?
Well, so the belief now is that it's fundamentally unpredictable, that what goes on at the quantum level, and it's really random. And my attitude to this randomness is that it's good, not bad. In randomness resides it seems to me, the creative principle. I think if the world were deterministic, as Laplace envisioned, it would be a less interesting world.
As Laplace fantasized, I will say.
Yes, the Laplace's demon that could, given the current state, could predict the future and also the past, since the equations of physics...
When Laplace is actually, even logically, when Laplace is actually saying that, he doesn't see that he's abolishing the very notion of time. He's making time being space, actually. It's what is weird. It's like everything will be here, but everything is not here, because actually the very idea of a motion is contradictory to the idea of pure determinism. And that, if you allow me, I'd like to challenge the idea, part of what you said, if I can allow myself. Just a little thing, the idea of a metaphor. Because my idea, but as a philosopher, and of course it's a discussion, so I don't want to make you feel, my vision of infinity in mathematics, usually people, let me explain. Usually people, when they think about infinity in mathematics, they think it's what is less and less concrete in mathematics and becomes like completely abstract, and it is infinity, and it's now, those people, they pretend that they can make calculation with something that, with infinity and numbers that you can't even grab, and you make, my vision, and after I will come back to quantum mechanics through this way, is actually the opposite. My vision is that when mathematics are dealing with finite numbers, like even in regular arithmetic, and you say 2 + 2 = 4 and things like that, it is this time that mathematics are, or is, I don't know if I say now, mathematics are the more abstract. Because in a way, when you say 1 + 1 = 2, you can't find in nature something that is sufficiently the same to be able to say 2. For instance, if you say 1 apple plus 1 apple = 2, say, is that a golden apple or another kind of apple? And even inside the category of golden apple, it's like if you were taking the category as being the thing itself. And so in fact you are becoming abstract because you're imposing something in reality that actually does not exist specifically in reality, even if you can make calculations and useful calculations, like for instance, if you want to sell apples and if you want to do things like that. But when mathematics is dealing, it's my view, but with infinity, it becomes more and more concrete, because at this time it gets closer and closer, not closer to reality, but closer to the real. Because in fact, reality is a construct that is made with the real, but a construct that we can actually grab, and we call it, for that reason, reality, because we perceive it, because we put it in comprehensive categories that are even the categories of our brains and things like that, etc., etc. But the real is this thing that is actually there, the things that are actually there, but you can't really perceive. And every time we try to put them in a category, they can't enter in this category because they are greater than this. They're always greater than this category. That's also the very reason why, when you try to add a certain object with another object, etc., etc., those objects are never exactly. But when you are talking about infinity, you're reaching infinity. In fact, you get closer to what is reality in this ungrabbable, I don't know how to nature. And now, when we are seeing quantum physics, that will be, in my way, a little bit the same. That when we were talking about physics in a very Newtonian way, and even on that aspect, in an Einsteinian way, so we think that everything enters into cause and effects that are finite cause and effects, like if everything was a box, a finite box, inside another finite box, etc., etc., and you can calculate everything, blah, 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 and all that. It's at that time that we are in the useful abstraction of our level of reality that is very useful. And actually even the difference between Newtonian physics and Einsteinian physics, it's also the fact that Newtonian physics is still useful, but we know it's less true than Einsteinian physics. But in my opinion, with quantum physics, that's the same. We are getting closer to what is actually more true, so that can't enter into causality, you know? But we take it the other way around. We think, oh, because it's not useful, we think it's less real or less concrete, but in fact, it's because it's more real that it becomes more and more ungrabbable. So that's the reason why, in my view, the more we get closer to quantum physics, and in mathematics, the more we get closer to infinity, that the more we are concrete, but the general public, they misunderstand the idea of concrete. They misunderstand concrete. I always distinguish with my students concrete and practical. What is practical is not concrete, because what is practical is what you have selected to be useful, but this selection is actually eliminating the real part of the real, because it's not grabbable and you can't do anything with it to be practical. You know, for instance, if you think about everything when you're biking, you just fall, because you can't take everything. You can't take everything into account. So consciousness is actually a process of elimination. Theories, when they don't deal with infinity, they eliminate part of reality in order to be able to do something with it. I don't know if I'm clear what I'm saying. So it's less concrete because it's more practical.
I can summarize what you're saying. As we get closer to reality in physics and in mathematics, it escapes us, because
exactly.
That's a sign that we are actually getting closer to reality.
Exactly, but I distinguish reality and the real on purpose. But because what you call reality is what I call the real, because something that can't even be being built to say real ET, you know.
Yeah, well, there are some problems because in quantum physics, reality is disappearing now. At the meeting we had last week, Anton Zeilinger commented that with entanglement, it looks like space is an illusion, and he referred to experiments which show that time is an illusion. So reality is sort of shaky now, and he said we need new concepts. What he proposed as fundamental concepts are randomness and information, but the latest physicists have been able to actually carry out experiments that were Gedanken experiments. And the results have been rather surprising. And the notion of reality seems rather shaky. So nobody quite knows what to make of these developments, which are good, that they're able to do experiments which challenge the traditional notion of reality.